So welcome to lecture 28. So from the last class we have started to do the circuit analysis when the circuit consists of magnetically coupled coils. So in that last class we have defined the two terms, that is self-inductance and mutual inductance. So self-inductance in coil 1, it was the linkage, total flux linkage, which was N1 into phi21 divided by I1. Similarly for second coil it was L2 is equal to N2 phi T2 upon I2, whereas the total flux will consist of the mutual flux plus the leakage flux that we have seen. Okay, and also we have defined the mutual inductance also, which was M12 was equal to M21, and that is suppose M, and suppose I would like to calculate the mutual inductance in coil 2 by the flow of current in coil 1, so that I can write as M21 is equal to the linkage N2 into mutual flux phi M1 over current I1. Okay, so with this also I can write as the linkage N1 phi 21 is equal to L1 into I1. Similarly for this also I can write N2 phi T2 is equal to L2 into I2. Similarly here also mutual inductance M into I1 we can write as N2 into phi M1, that way. Okay, now suppose I have two coils, and in that the time varying currents are flowing in it. So let me draw the magnetic circuit first. So suppose I have the magnetic core like this. Okay, and to this more this way. So suppose this is my magnetic core, and to that magnetic core I have wound the wire like this, say this way. Okay, yeah. Similarly on the secondary side also, suppose my sense of winding is like this. Yeah, with some turns, say I have and 1 turns here and 2 turns here. Okay, and to this let me energize the primary coil. Let me give the name A and B for example, and this is my coil C and D. Okay, and to this suppose energizes. So with the energization of coil 1, let me see the time varying current I1 is flowing in it. So when it is flowing in this particular direction, what will happen? According to right hand thumb rule, the flux will produced. And what is the direction of flux? Direction of flux will be this way. By right hand thumb rule you can calculate. So this is the direction of flux, and there is the leakage flux also here. Now I will neglect it. Suppose this is my mutual flux flowing in it, and if it is flowing this way, what will happen? It will link with this coil L2, okay, or it will link with coil 2 here. So now what will happen? By linkage of this, there will be EMF induced according to Faraday's law of induction. Okay, so now what is it? There will be the EMF induced in primary coil, also with secondary coil, which will be time varying. Now what will be my E2 of t? So my E2 of t will be the rate of change of the flux linkage, so which will be N2 into phi M1, and this also I can write as N2 phi M1 we have defined as M into I1. So this also I can write as M d dt of I1. Okay, similarly if I would like to draw the EMF induced in coil 1, so which will be simply L1 E1 of t, which is E1 of t, which will be say d dt of your flux linkage N1 phi T1, which I can write as L1 dI1 by dt. Let me properly here. So it will be N1 dI1 by dt. Okay, so now here I can decide very easily the polarity of V1T, because current is flowing in this way. So this I will definitely define that this is positive and this is the negative polarity. So the problem with the decision of polarity for E1 of t is over. That is so. Now here I have also to decide what will be the polarity across C and D due to the EMF induced as T of t by the mutual flux phi. Okay. So now here my question is what will be the polarity of C and D, that I have to decide. Okay. So sometime, and this polarities will be your instantaneous polarities, right? Okay. So now these polarities can be decided by the use of Lentz's law. And what Lentz's law is says that EMF induced in such a way that it will try to oppose the cause for which current is due. So polarity of AB is good. Okay, this is A is positive, B is negative. Now polarity of CD may be, there will be the two types, there will be the two ways. One may happen that C will be positive, D may be negative, or what may happen, C may be negative and D may be positive. This way only we have to decide. Now out of these two, which one is correct, that we have to basically see it here in order to do the dot convention. That was our problem here. Okay. So to see it, let me see what will happen now. As we said, in order to decide this polarity C and D, I have to use Lentz's law. Okay. So in order to do that, I have to find out how much consequent current will flow in coil 2. So what I'll do, I will try to allow the current flow in coil 2. So this can be done by connecting external circuit to it. So let me draw that. Suppose this is my coil 1. With through it I1 amount of current is flowing, L1, and say this is my coil 2, and here some current is flowing. It's EMF induced in this case, so due to which its consequent current has to flow. Let me allow this. So I will allow it by connecting through switch here, and let me attach the external circuit over here, say R. Okay. So this will be, what is the value of EMF induced? It will be L1 di1 by dt with this polarity. And what about this value? This value will be, because linkage is here M, so mutual inductance is M into di1 by dt, that I have defined. Okay. So this is C and this is D. So what should be C, positive or C negative, that we have to decide. So suppose I'll with this like this I have connected the external circuit, and let me allow to flow the current in coil 2. Okay. So in order to decide whether C is positive or negative, again let me draw the magnetic core once more. This way, suppose. Okay. Now suppose I have sense of windings like this, wire wound on it. Okay, and here I have the wire wound like this. Okay. And I know that this I1 current is flowing in it, due to which this flux phi M1 will produce, which is in phase with I1, and here EMF induced as E1 of t. Now it will be E2 of t here, and I have to this is my A and B terminal, this is C and D. Now to decide the polarity of C and D. To do that, let me assume that this is negative C and D is positive, for example. So if I'll assume my polarity is like this, then what will, suppose, and this is my resistor connected to it. So if these are my polarities, what will happen with the flow of current? The current will flow in this way. Okay. So current will flow like this, and then this, then this, and this, and it will be like this. Okay. So now if these are the directions of current, then what will happen? Due to the flow of current, again obviously there will be the flux induced, or flux will produce, right? And what will be the direction of flux? That can be decided using our thumb, right hand thumb, right? So if I am putting the coil like this, So what will happen with the direction of flux? It will move in this direction. Let me draw with other plane. So the flux will move in this direction, phi t1. Say this I will call phi m2. So in this case, what is happening? Phi m1 is, phi m1 is also moving in this direction, and phi m2 is also moving in this direction. So if I'll keep it the direction like this, negative with C is negative and D is positive, what is happening? It is strengthening the flux, but it is not, it is strengthening the cause, it is not opposing the cause. So Lenz's law will not satisfy. So whatever the polarity I have assumed, this will not be correct. Okay. So Lenz's law is not, because it is, Lenz's law is not satisfied because it is not opposing the cause, that is by which current is due. So now let us take a D positive and C positive and D negative. So in order to do that, let me again redraw the magnetic core. See this way to this wire wound like this with the sense of winding. Okay, suppose this is the case, and these are the terminal names A and B. This is the flow of current I1, and due to which the magnetic flux will flow this way. Let me name it phi m1, and now I have drawn the likewise sense of winding I have, which I have drawn before. So this, okay. So suppose these are my polarities C and D, and say now my C is positive and D is negative, and to this external circuit I will connect this way. Okay. So now if I have assumed this polarity, now what will happen? The current will flow in this way, then this way, this way, this way, and this. Okay. So now my current direction is like this. So now if I'll use the right hand thumb rule, then what will happen? This way. Okay. So if I'll use the right hand thumb rule, then this is the flow of current. So what is the direction of the flux? It will be opposite direction. Okay. So the direction of flux will be opposite. Let's say this is phi m2, and which is opposing to the flux phi m1, and hence Lenz's law is satisfied here. That's why the polarity of C and D are positive and negative. Okay. So why we did? To identify the dots, basically for that only we need it. Okay. So let me draw the resultant on for that. So what is the resultant? It will act as the source, whose magnitude will be L1 di1 by dt, with this polarity positive, negative, A and B, and current I1 is flowing in it. Similarly, what about here? This EMF induced, whose value will be M di1 by dt, and the terminals are C and D, and what will be the polarities of the EMF induced? It will be positive and negative, due to which it will satisfy the Lenz's law. Okay. Now, and this all can be decided by the sense of winding, how you have wound the wire, right? So if on pen and paper, if I will draw like this, and I'll ask you, this is wound, this is the wire I have wounded. Similarly here also. So in this case, it is highly difficult for me to decide the flow of the flux, right? So in that, it is highly impossible for me to find out the dots. That's why to find out the dots, or to find out the polarities of the EMF induced, I should have the sense of winding. Okay. So from this onwards, I will not draw the magnetic core or magnetic circuit. To shortcut, we will draw to indicate the couple coil like this. Okay. And this is my terminal A, this is my terminal B, I1 current flowing in it, and this will be the mutual inductance. And what will happen? Dot is here, this is positive, negative, or dot, instead of dot I am saying these are the polarities, and these are the polarities for C and D. Okay. So this polarities, once I have drawn, with this I can mark the dot. So this positive will indicate the dot. Manufacturer will do basically well, and it give me the sense how the winding has been wounded, right? So dot means the positive side of it, or the same side, right? Sometime what, because these are the instantaneous polarities, sometime what may happen, A is negative, so at that time this dot, what will happen, this will be negative, this will also be negative, so same side it indicates. Okay, so this way you with the help of the dots you can decide the polarities. Fine. Now again another magnetic circuit, let me draw it to see how the linkage will be with another sense of winding. So here I will wound the primary coil like this. Okay, to this I have one flowing, and this mutual flux flowing in this direction phi and 1, and suppose I have wound the coil like this now. Okay, so suppose this is my C and D terminal, so this is my phi m. So what will happen now, suppose this is the external circuit I will connect. Okay, so in order to decide the polarity, what will happen, suppose I will take it C as a positive and D as a negative, so with this current will flow this way, like this. Okay, and if this is the case, then what will happen with the right hand thumb rule, the flow of the direction of flux will be in the same direction as of phi m1. Okay, so what will happen, again the flux will strengthen, so it will not satisfy the Lenge's law. So as opposite to it, if I'll change the polarity, instead of C positive, now let me make it C is negative and D is positive, so what will happen, let me flow the current like this, so this way it will flow, and this. Okay, so now if it is like this, if the current flowing direction this, and if I'll apply the right hand thumb rule, then what will happen, the flux will move in upward direction. This direction flux will move, and I observe that it will oppose this flux, and then Lenge's law will satisfy. Okay, so what is the resultant direction for this? The resultant direction for this will be negative and positive, means what, the polarities will be like this. Let me draw here. So suppose this is A, B, C and D, and these are the polarities of A, B, current is flowing, and what about here, C will be negative and D will be positive. So what about the dots here, dots will be this way to indicate that the linkage will be opposite. Okay, so this way you can decide the polarities of the EMF induced in other coil, okay, with the help of the dots. So this is called as the dot convention. Hence dots are very much important for us to decide the polarities in coupled coils. Okay, and obviously there was the mutual inductance M, this is L1, L2. Okay, so this is the importance of the dot convention. Now let us write now the equations when the coupled coils are in series and in parallel. Okay, so first we'll see the coupled coils in series, then how to write the equations. So suppose I'll draw, this is one coil, okay, and say this is second coil, and they are linked with this much mutual inductance, and then to this supply voltage is given, say time varying. So suppose this is my L1, L2. Now if I would like to write the equation, it is highly difficult for me because I have to find out I also. So suppose this is I. Okay, so now I don't know the polarities. Okay, so in order to find it out, or in order to write the equation, I need the polarities. So suppose I have given the polarities like this, one is here and other is here. Okay, let me write, this is my A, B, C and D, basically B and C are same point. So now what will happen here? So if this is the case, current is flowing through L1. Now the coils are coupled. That's why now there will be two EMF induced. One will be due to self inductance and second will be due to mutual inductance. Okay. So now one will be this EMF L1 di1 by dt, and the second will be due to the mutual inductance M by the flow of current in coil 2. Okay, so this is my A and this is my B point. Now we have to decide the direction of the polarities. So what it will simply current flowing it into the dot. So A side is positive, B side is A side is positive and this side is negative. Now in order to decide M, the polarity for this M di2 by dt, now what, just see here, current is same, so current is entering into the dot in coil L2 also. So dot side is positive here and this side will be negative. Okay, so this way we can decide the polarity. Now let us come for the L2 coil. So here also there will be, so here B and C. So the value of this will be L2 di by dt, and here I found that I1, our current is same basically, so I will not mention I1 and I2. So it will be basically L2 di by dt, and one more thing will be there, EMF induced will be M, and due to flow of current in coil 1, so it will be same di by dt. Now what are the directions? L2 will be same, this will be positive, this is negative. Okay, and again I observe that current is entering into the dot side, so this will be positive, this will be negative, and to this we have connected the voltage source positive negative here. So this is my V of t and this is my I of t. So what is the equation now? V of t will be to have the voltage balance, to satisfy the KVL, it will be L1 di by dt plus M di by dt plus L2 di by dt plus M di by dt. So what will be the equivalent inductance? It will be L1 plus L2 plus 2 times M di by dt. So this will be my L equivalent. Okay, so this way you can write the equation. Now second example, with slight change in their connections. So suppose this is my one coil and here one more coil is there which is like this. They are mutually linked, assume that this way. Okay, and this point and to this point I'll give the supply voltage with like this. Okay, suppose this is my V of t, current is flowing this way, and dots are, suppose this is my one dot here and this is the second dot. Say this is L1 and L2. Now what I observe here, let me mark the name. Suppose this is A side, B, this is my C side and this is my D side. Okay, so now what will happen? Yeah, for L1 what can be, it can be replaced by L1 di by dt plus M same di by dt. Okay, so two EMFs because of the mutual thing. So what is the polarity of L1 di1 by dt? It will be current entering into the dot, so it will be plus and minus. Now what about this? Here the EMF induced will be because of the current flow it into it. So here what is happening? Current is entering in without dot. Okay, so now what will have, dot side will be negative and without dot side will be positive, because current is not flowing into the dot but current is flowing in the other terminal of dot. Okay, so this will be the polarities for A and B. Okay, now so let us write for C and D. Okay, so now current is flowing this way, so now this is the D side now. Okay, so this will be what, positive and this will be negative because current is going this way, so it will be L2 di2 by dt or simply di by dt. Then one more thing, I'll put this one more EMF will induce whose magnitude will be, whose value will be m di by dt. Now we have to decide the direction here. So what will be the direction? Because current is, this will be due to the flow of current, so I is coming here, is entering into the dot, right? So dot side will be positive, so dot side will be positive, this side means it will be, this will be positive, this will be negative. Okay, and to this source is connected, not to the D. No. So this is not correct. What will happen? B is connecting to D basically, and now C and with A terminal there is the voltage source V. Okay, so what is the equation now? V of t will be L1 di by dt. Here what is happening? Voltage rise. Okay, so if I'll do, so it will be now reverse, is m minus m di by dt. This is plus, so it will be plus L2 di by dt. Okay, and here this was negative, so then rise, so it will be minus m di by dt. And basically how to write that is all the addition of the voltages according to KVL. This is voltage rise, this is voltage drop, so it will be minus L1 di1 by dt. This is rise, so it will be plus m di by dt, not I1 and I same. Here it is the drop. Okay, so it will be minus L2 di dt, and here it will be voltage rise, so it will be plus m di by dt, right? So now what will happen? V will be equal to L1 di by dt plus L2 di by dt plus minus 2 times m di by dt. So your equivalent will be minus L1 plus L2 minus 2 times m di by dt, which is Leq. Okay, so this way you can write. Now suppose I'll see now the parallel circuit. So when parallel circuit means when the couple coils are in parallel form, how to write the equation. So suppose I have this coil to this EMF is there, V of t. Okay, and this and these are connected this way parallelly like this, and this is also something like this. So this is my A and B, and suppose this is my C and D. I have to give the dots and they are coupled mutually, so M, and this is L1, L2, dots are here and this dot is here. Okay, so now let us write its equivalent representation. So now suppose this current is I. Okay, so now what will happen? Here is parallel form, so I1 current is flowing here, so if it is the case, then this will be I minus I1. Okay, so now let us write it for this AB. What is it? Current is flowing into the dot, so it will be L1 di1 by dt plus again mutual inductance with di2 by dt, not I2 now, I2 will be this current in coil. So what is this current? It will be I minus I1. Okay, and what about the polarity? Simple, because current is entering into the dot here also and here also, so positive and negative. Same way for this coil CD, this is for A and B. Let me draw for C and D also. So it will be like this. So C and D, it will be L2 di2 by dt. What about the polarity? Simple here. And for this, again in coil 1, current entering into the dot, so your mutual inductance M into di1 by dt, so it will be same, plus and minus, and they are connected parallelly, CD, and to this source is connected with V of t as a time varying. Okay, and these are the polarities for V at t also. Okay, now let us write the equation. So what will happen? V of t for AB will be L1 di1 by dt plus M. Oh, I2 will not come. This will be I minus I1 plus M d dt of I minus I1. Here also I is not there. Okay. So this is first equation. Okay. What about second? Again same, V of t will be, for second case it will be L2 d dt of I minus I1 plus M di1 by dt. Now I would like to write for its the equivalence. So what I should write, I should be able to express into V of t into something into I of t. So I want to remove I1. So for that we know the voltage across both A, B and CD will remain same. So I'll equate the right sides. So it will be L1 di1 by dt plus M di by dt minus M di1 by dt. For this equation 1, what is that for right side? L2 di by dt minus L2 di1 by dt plus M di1 by dt. Now let me write all the di1 terms. So di1 by dt will be this L1, then minus M, this will also, and here it will be right side, so no plus L1 minus M plus L2. Okay, which will be equal to L2 minus M di by dt. This is not I1, that is what I thought, how it can. This is simply di L1, I'm sorry, so this is L1 di by dt, M di by dt minus M di1 by dt, L2, and this will. So if we will shift it here, so now it is correct. Okay. So L2d, this will be L2 di by dt minus L2 di1 by dt plus M di1, and this will be L1 di by dt di1. No, this is correct only, di1. Yeah. So if you solve, you will get it di1 by dt is equal to L1 plus L2 minus M. So now I can write di1 by dt. This is correct. Okay. So this di1 by dt will be L2 minus M over L1 plus L2 minus M into this di by dt. Okay. Yeah. So now once I know di1 by dt, now I can substitute any one of the equations. Suppose my equation is V of t will be equal to L1 di1 by dt plus M di by dt minus M di1 by dt. Okay. Okay. So basically what we did, L1 di1 by dt plus M, we have equated L1 di1. Let me, there should not be any confusion. Okay, so first we know that voltage we have written that way. This is correct, this is correct. Now we'll equate the RHS, L1 di1 by dt plus M di by dt minus M di1 by dt, which is equal to L2 di by dt minus L2 di1 plus M di1. Okay, and then I will collect all the terms in di1. So L1 di1, then minus M di1, and L2 I will shift it here. So that's why it came here. And on right side I will write only di. So on right side L2, and this M I am shifting here. So di1 by dt I can make it this way. And now this di1 by dt I can put it in this equation. So now what will be the case? Now v of t will be L1 di1 by dt, means it is L2 minus M upon L1 plus L2 minus M plus M di by dt. Okay, and minus M, it was L2 minus M over L1 plus L2 minus M into di by dt. Now LCM is L1 plus L2 minus M. Okay, L1 plus L2 minus M, and if I do cross multiplication and all, so I'll get it L1 L2 minus L1, this L1 L2 minus L1 M plus L1 M plus L2 M minus M square minus M L2 plus M square into di by dt. Okay, this will vanish with L plus L1M minus M1M, then L2M with ML2. So what is the remaining? M square also will get it cancelled. Okay, so what will be the equivalent? V of t will be L1 L2 upon L1 plus L2 minus M into di by dt. So this is my equivalent. So when the couple coils are in parallel form, what it will be, the equivalent inductance will be L1 L2 divided by L1 L2 minus M or plus M, depends on the dot convention, right? And whereas they are in series, then it is L1 plus L2 plus minus 2M. Okay, so that way also you can calculate the equivalent inductance and all. So this way, with the help of dot convention, we will be able to write the equations, and once we know the equations, we can do the circuit analysis. Means I can find out any value of voltage or current in couple coils. Okay, so today we stop here. Thank you very much.